Hi, this is Mrs. Bridges Matthew, redelivering a presentation that was given a few years ago by Dr. Frank B. Flanders and Catherine Hudson of the Georgia CTAE Resource Network Curriculum Office. Essential questions. What are the different engineering disciplines? What is the occupational outlook and expected salary of engineers? Now, this video accompanies the quiz for careers that I put in the Edmodo for your homework assignment. Engineers are constantly evolving. Some disciplines have become extinct because of society's changing needs. As we progress through this new millennium, it is inevitable that new engineering disciplines will develop and more will fall to the wayside. Acoustical engineering. Plan, perfect, or improve the sound of an architectural space. Deals with two basic properties of sound, reflection and absorption. Investigate how different noises and background sounds affect productivity in a building. Sets the mood of structure's environment by deciding what it will sound like. Work on an architectural space can range anywhere from examining the innumerable surfaces in a church to drawing to CAD plans, CAD plans, computer aided design for a subwoofer enclosure. HVAC or air conditioning systems are the hardest sounds to eliminate in large, high productivity office spaces. Acoustical engineers are in high demand, but there are few of them. Automotive engineering. Plan, coordinate, and implement the specifications for a new car, engineering every part. Design and draw automotive parts. Combine the automotive parts into components. Integrate the components into the car system. Make the mechanical aspects of the car fit into the aesthetic design. Emissions laws, cost of materials and development, performance requirements, and consumer demands create challenges. Requires a degree in engineering, interpersonal and communication skills, ability to multitask, technical knowledge, and design experience. Aerospace engineering. Design, develop, test, and help manufacture aircraft, missiles, and spacecraft. Develop new technologies for military and commercial use. Can be divided into two fields. Aeronautical engineering works with aircrafts. Astronautical engineering works with spacecrafts. Can specialize in many fields, ranging from propulsion to thermodynamics. Requires an engineering related degree from a 2 or 4 year college, completion of a formal training program, and licensing or examination. Agricultural engineering, concerned with the production and processing of agricultural products, which are critical to our ability to feed the ever expanding world population. Can specialize in many fields: power machinery, bioengineering, soils and water, electrical technologies, food processing. An example of an agricultural engineer's work is designing and implementing an irrigation system for crop production. Bioengineering, the application of engineering principles to biological systems. Encompasses many fields of study, including chemistry, physics, technology, and medicine. One of the newest and fastest growing disciplines. Applies the fundamentals of engineering to meet the needs of the medical community. Requires an undergraduate and often graduate degree in bioengineering. Examples of their work: genetically modifying a plant or animal to produce a disease resistant strain. Developing the chemical process necessary to make an artificial kidney function. Chemical engineering. Take what chemists do in a laboratory, apply fundamental engineering, chemistry and physics principles, and design and develop processes to produce products for use in our society. Solve problems that involve the production and use of chemicals. Focuses on chemistry and the chemical nature of products and processes, unlike other disciplines. Design of large-scale chemical production facilities is the most common employment. Must develop processes that minimize harmful waste since many chemicals and their byproducts are dangerous to people and the environment. Requires a bachelor's degree and a strong math, science, and computer skills. Civil engineering. designing and supervising the construction of roads, buildings, airports, tunnels, bridges, and water and sewage systems. Main objective: design systems that are functional, efficient, durable, and minimize harm on the environment. Affected by population shifts, urban planning and renewal efforts, zoning laws, and building codes. Structural engineers are the most common type of civil engineers. They are concerned with the integrity of the structure of buildings, highways, and bridges. Other types of civil engineers are transportation engineers, surveyors, urban planning engineers, and construction engineers. Computer engineering. Design and build computer-related hardware products for many applications, such as personal computers, cell phones, automobiles, and even washing machines. Apply the theories of science and mathematics to design hardware, software, networks, computer chips, and processors. Often work in teams. One of the fastest growing disciplines. Difference between computer science. Computer scientists focus on software and its optimization. Computer engineers focus on computer hardware or the machine itself. Security is becoming a huge concern of computer engineers. Construction engineering, concerned with the management and operation of construction projects. Interested in improving construction methods and materials to make them safer, more reliable, cost effective, and environmentally friendly. Incorporate technical, financial, and legal requirements into a plan to meet project deadlines. Requires project management skills and knowledge of computer tools. Electrical engineering, responsible for the design, development, testing, and supervision of the manufacturing of electrical equipment, such as household appliances or guidance systems for satellites. Work with all products and systems that use electricity. Concerned with making their designs efficient, long-lasting, cost-effective, and safe. The most populated and traditional of the engineering disciplines can be divided into 8 areas: computer, circuits and solid waste devices, instrumentation, bioengineering, communications, control, signal processing, or power. Environmental engineering. Apply engineering principles in order to improve and maintain the environment. Uses science to make the world a safer place for humans and animals. 3 components of environmental engineering: disposal, disposing industrial and residential waste; remediation, cleaning a contaminated site; prevention, reducing or eliminating the amount of waste from the manufacturing process. Requires knowledge of engineering fundamentals and environmental laws and regulations. Fire protection engineering. Design fire sprinkler, alarm, and exit systems, as well as aid in the investigation of fires and explosions. Analyze risk of major facilities and consult with architects on large projects. Can work in private or public sector for consulting firms, petrochemical societies, federal agencies, insurance companies, and in healthcare industries. Food process engineering, concerned with providing healthier products to consumers who increasingly rely on food products. Involved in the efficient and safe processing and delivery of food products. Design processing, handling, and packaging equipment for the food industry. Can work in food, chemical, and pharmaceutical industries. Genetic engineering. Use science to research genes found in the cells of plants and animals to develop better products. Demand is growing, surrounded by complicated political, economic, and moral conflicts. Specializing in the study of a disease and its effects on humans in a common focus. Must follow rigid safety measures and work with dangerous chemicals, electron microscopes, and gene guns to carry out research. Can be divided into 4 categories: human, animal, plant, and microorganism. And believe it or not, genetic engineering has been around for thousands of years. Geological engineering. Use science to work with land and water. Range of tasks vary due to the ever-growing and changing field. Investigate sites of major land-related projects, such as bridges or tunnels. Mitigate toxic waste and land contamination. Use physics to predict the flow of water. Build and maintain Earth-related power sources, such as hydroelectric planes. Requires a graduate degree. Industrial engineering. Design, improve, and install integrated systems of people, materials, and energy. Involves the integration of technology, mathematical models, and management practices. Traditionally work on a factory floor, but skills can be applied to many other applications and industries. Focus on four main areas. Production is concerned with optimizing product production by reducing costs and production time and increasing quality and reliability. Manufacturing addresses the concerns of each individual station in the production process and optimizes the actual material processing. The human factors area studies the interfaces between people, machines, and objects. Operations research involves mathematically modeling systems to identify ways to improve them. Manufacturing engineering applies science and math to the design, development, and implementation of manufacturing systems, i.e., they produce goods. Often involves the supervision of skilled craftsmen. Make decisions about technology, machinery, people, and money to produce high quality goods at affordable prices. Often work in teams to launch new products. Partner with design engineers, marketing specialists, supply chain managers, human resources, and accountants. Must know how to use resources, including machines, robots, people, computer based tools, information networks, and money. Work at the core of industrial companies and can therefore easily advance into management and executive positions. Marine and ocean engineering, concerned with the exploration of oceans, the transportation of products over water, and the utilization of resources in the world's oceans, lakes, and seas. Design and operate ships, boats, and submarines, especially their propulsion, navigation, and steering systems. Design underwater pipelines, offshore drilling platforms, and offshore harbor facilities. Study wave action and design ways to reduce erosion while protecting marine life. Control and treat pollution in the ocean and find alternative sources of energy from the ocean. Materials science engineering. To develop new materials, improve traditional materials, and produce materials that are economical and reliable through synthesis and processing. Concerned with four components materials. Structure. Study the molecular, bonding, and chemical composition of materials. Properties. Optimize the strength, crack growth rates, hardness, and durability of materials. Processes. Different processes of creating materials give materials different properties. So materials engineers design processes that give each material its desired properties. Performance. Ensure that materials meets its performance demands by designing test procedures that make sure these requirements are met. Work with materials such as metals, ceramics, plastics, and composites. Mechanical engineering. Design, produce, operate, and service machines and mechanical devices. Second largest engineering discipline after electrical engineering, often involved in automating time consuming or expensive procedures. Composed of two main divisions. Design and controls is concerned with the strength of machine parts and the stress that each part will be subject to. Developing tools that help the design engineer design a machine, controlling machines through mechanical, hydraulic, and digital controls, minimizing the unwanted noise of a machine. Thermal science is concerned with the flow of fluids and engineering,